Hey everyone, and welcome back to WhyDecrypted, where science, mystery, and the impossible collide. Imagine this: you board a spaceship, spend a single year travelling close to the speed of light, and when you return, decades have passed back here on Earth. Your friends are older, history has moved on. Entire generations might have been born, but you've only aged 12 months. It sounds like pure science fiction, but it's actually science fact. This is what happens when speed and time collide, a consequence of Einstein's relativity. Or as Ben likes to frame it in the script notes, the universe rewards us for going fast. In 1905, Albert Einstein shook up physics with his theory of special relativity. For that, we thought of time as absolute, ticking away like a universal clock. But Einstein showed us something radical. Time doesn't flow at the same rate for everyone. The faster you move, the slower your clock runs compared to someone standing still. This effect is called time dilation. And it isn't just abstract theory. We see it every single day. GPS satellites orbiting Earth run on a slightly different time than we do down here on the ground. Engineers literally have to correct their onboard clocks, or your Google Maps directions would drift further off course every day. Ben summed it up nicely. Speed bends time, not in sci-fi, but in your pocket. One of the clearest illustrations is the famous twin paradox. Imagine two identical twins. One stays on Earth, the other rockets away at near light speed. From the traveller's point of view, only a few years pass. But when they return home, they discover their twin has aged by decades. At first it seems impossible. After all, shouldn't each twin see the other as moving? So who's actually right? This puzzle was a favourite back in Einstein's day, and it still catches people off guard now. Ben actually wrote in the margins of this script, "This is the fun part." And he's right. It only looks like a contradiction until you dig into the math. The trick lies in the path each twin takes through space-time. The twin who stays on Earth follows a straight path. No interruptions. The traveller doesn't. They accelerate at launch, turn around at some distant star, and accelerate again to return. That change in motion breaks the symmetry. When the equations are worked out, it's clear. The travelling twin really does age less. Their clock literally ticks slower relative to Earth. We've even confirmed this with high precision experiments. The so-called paradox isn't a contradiction at all. It's just relativity in action. Or in Ben's words, it's a discount time machine. And I suppose it is. All we need is some kind of spaceship propulsion system and fuel that we haven't yet invented. And this all sounds abstract until you look at the real-world evidence. In particle accelerators, unstable particles called muons normally live just a millionth of a second. But when you accelerate them to close to the speed of light, they last much longer, literally aging slower because of time dilation. Even astronauts experience it. A 6-month stay on the International Space Station shaves off a fraction of a second compared to time on Earth. It's tiny, but it is measurable. Back in 1971, physicists carried atomic clocks on commercial airliners around the world. When compared to clocks that stayed on the ground, there was a clear, measurable difference, just as relativity predicted. Ben likes to point out that technically we've already built time machines. They're just not the kind you see in Back to the Future or Doctor Who. Here's where it gets astonishing. This isn't just a physics curiosity. It's a real doorway to the future. If you could travel at 99.999% the speed of light for what felt like a year on board your ship, you could come back and find that hundreds of years have passed here on Earth. Civilizations could rise and fall in what to you was just 12 months. It's not a two-way time machine. You can't go back, but it means that future is accessible in a very real, very physical way. This is why science fiction borrows from relativity. Interstellar famously used the slow clocks near a black hole, but the principle is the same. Time itself stretches and bends. And Ben, who's ever the optimist, prefers to skip the paradoxes and just say, who cares about the math? Let's just go and find out how the story ends. I completely disagree. I think the journey is what's important, but that's why me and Ben work so well together. So why does travelling close to the speed of light let you time travel? Because motion reshapes time. The faster you move, the slower your clock runs compared to the universe around you. It's not a way to revisit the past, but it does mean the future is waiting. And we already know how to reach it. All we need is a ship that can take us close enough to light speed. Until then, the equations don't lie. Speed is the closest thing we have to a real time machine. And if Ben had his way, we'd already be booking tickets. But that, as always, is a paradox for another day. Thank you ever so much for being here. I've been Tom, the script was by Ben. This has been WhyDecrypted, because nothing is quite what it seems.